Hello and welcome back, everyone. This is Noah again, and we are going to look at some technicalities of functions today. We're going to start this video out talking about the formal definition of a function. We've talked a bit about how to use a function, how to evaluate a function, how to solve an equation given a function in different forms, verbal, symbolic, graphical, set of points, a table, things like that. We've looked at some function operations. We've talked about the domain and range in some different scenarios. And we've looked at translating between those different relationships. But we actually haven't really formalized what a function is. So we want to get into that today. We're going to use some examples where we determine whether a set of points actually constitutes a function or not. And in order to really understand how to even approach that question, we really need to just go over the formal definition of a function. So let's read this and maybe add a little bit to it as we go here. A function is a kind of relationship between inputs and outputs. That is, it is a rule or multiple rules that determines which output corresponds to which input. For this rule or set of rules to be deemed a function, each input must correspond to one and only one output. Another way to say this is that a function is a relationship between inputs and outputs such that each input only produces one output. Okay, so if we have a relationship between inputs and outputs where you have an input and it gives you more than one thing out, then that wouldn't be considered a function. So this might seem more complicated than it is. Let's take a look at an example. What we really mean is that if you apply a rule to a specific number, you aren't expecting to get multiple outputs for that single input. For example, wouldn't it be a little weird if we had f of x equals x plus 2 produce more than one number if you plugged in 5? We would expect that if we plug in 5, we will only get 7, right? 5 plus 2 is 7. We wouldn't expect to get 7 and another number, 7 and 12 and negative 8 or what have you. If we take 5 and plug it into f of x equals x plus 2, we're expecting to get 5 plus 2 equals 7 and only 7. So we do consider adding 2 to a number a function. If I take a number and I add 2 to it, I'll always get the same thing for any specific number. If I plug in 6 and I add 2, I'll always get 8. If I plug in 9 and add 2, I will always get 11. So there are relationships between inputs and outputs that are not functions, and they're perfectly good relationships as well. They work, they make sense, but there are things that don't behave in the same way. So, and we sometimes consider them more complicated than a function if they produce more than one output for a single input, because we have to consider those multiple outputs for that single input. For example, take a look at the relationship y squared equals x. If we input x equals 4 and say what are the y values, what are the outputs of this, we could have y equal 2 and negative 2, right? If y is 2, we square that, we get x equals 4. If we have y equals negative 2 and we square that, negative 2 times negative 2 is also positive 4. So in this relationship for x equals 4, there are two different y values, two different outputs for that single input. Now again, there's nothing wrong with this. This is a perfectly good relationship between x and y. We can say x equals y squared or y squared equals x and talk about how those inputs and outputs relate to each other in that way. We simply don't consider this relationship a function, right? So this is like, the reason we talk about relationships that are functions and not functions is because there is a distinction in how they behave. It's the same reason why we have like a pine tree and a fir tree. They're both trees, but they have their differences, so we give them slightly different names. We talk about them in slightly different ways so that we can discuss the differences and categorize this tree in pines and that tree in firs and so on, right? As humans, the way we think, the way we communicate is really a lot of categorizing things and noting both the similarities and the distinctions between the different things that we see and hear and smell and touch. And which one am I missing? Taste. Yeah, we talk about the distinctions in taste a lot, right? We have different words to describe different things. So in relationships between inputs and outputs, there are distinctions between the kinds of relationships that we could look at. So let's try and make a little bit more sense out of this by looking at some examples. We want to determine whether the following set of inputs and outputs constitute a function. And then we're going to talk about the domain and range of each of these examples. So I want to make a note here real quick before we jump in that even if a relationship is not a function, it still has inputs and outputs, and we can still talk about its domain and range. We can still say what are all of the possible inputs for this function and what are all of the possible outputs for this function. We can still say what is the domain and what is the range, even if it's not a function. So we'll do that whether or not we determine these relationships to be functions or not. So part A gives us a set of points where the points are more abstract. We have the first point is A1 comma pretzels, saying that if we input A1, we output pretzels. If the second point is A2 comma Fritos, saying if we input A2, we'll get out Fritos. The third point is A3 comma Fritos, so if I type in A3 into a vending machine, we get out Fritos. The fourth point says A4 comma Cheetos, so if I type in A4 to the vending machine, we'd get out Cheetos. We'll go a little faster now. The next point is B1 comma Butterfingers, and then we have B2 comma Three Musketeers. Then we have B3 outputting Skittles. We have B4 outputting Snickers. We have C1 outputting Spearmint Gum. We have C2 outputting Cinnamon Gum. We have C3 outputting Mints, and we have C4 outputting Lifesavers. So we do see that A2 outputs Fritos and then A3 also outputs Fritos, but let's note that A2 only outputs Fritos and A3 only outputs Fritos. So for the input of A2, we only get Fritos out. For the input of A3, we only get Fritos out. So each of those inputs only outputs one thing. And if I look through the rest of the list, we see A1 only outputs pretzels, A4 only outputs Cheetos, B1 only outputs Butterfingers, and I can continue looking through that list and realize that none of those inputs outputs more than one thing. And so we can consider this a function. So yes, this relationship does constitute a function. And I'm going to be specific in describing why. Each input only gives a single output. And let's imagine if this wasn't a function. Say I had an input like or let's go with B2, outputting not just Three Musketeers, but also Snickers. That's a perfectly good, that's a vending machine still. It's now outputting two things for a single entry. Maybe it's designed that way, maybe it's broken, maybe you typed that in and kicked it at the same time, and now you've got two things coming out at the same time. But that would no longer be considered a function, and generally we design this vending machine to be a function so that each input gives you exactly the one piece of candy that you're hoping to get out. All right, let's talk about the domain and range here. The domain is the set of all possible inputs for this function. That would be the A1, the A2, the A3, the A4. We have B1, B2, B3, and B4. And then we have the C's, C1, C2, C3, and C4. Put that in our set notation to say that's the set of all the possible inputs for this function. Then we're going to look at the range. The range is the set of all the possible outputs. So what candy can we get out of this machine? And we can get pretzels out. We can get Fritos out. Fritos comes out of two different slots, but we're just going to list it once for the range, right? The range we don't have. We're just saying what are all the possible outputs. We don't have to note whether or not they can be gotten to in multiple ways. So we have pretzels, Fritos, Cheetos, and we have candy bars, Butterfingers. We've got Three Musketeers. Got Skittles, we've got Snickers, we've got spearmint gum, we've got cinnamon gum, we've got mints, and we've got lifesavers as all of the possible things we could get out of this machine. And that's it. We've got our domain, we've got our range, we've determined that yes, this is a function. So let's move on to the next example, where we're now going to look at something with numbers instead of this abstract thing, right? The abstract's nice for us kind of getting a sense of what we're talking about here, and now let's do this a little bit more mathy. All right, so here I have a set of points. The first point's 1, 6, the second is 2, 6, the third is 3, 8, the fourth is 4, 9. What we notice is that the number 1, that first input, only outputs 6. The number 2, the second input, only outputs 6. The number 3 only outputs 8, and the number 4 only outputs 9. So no input outputs more than one thing. Yes, it's true that 6 can be gotten to in 2 different ways, but each input only has one output. So yes, this is a function. Each input only has one output. Then we'll state the domain. The domain equals the set of inputs. Here we have 1, 2, 3, and 4. And then the range is the set of all the outputs. In this case, we have 6, 8, and 9 as the things we could possibly get out of this function. All right, let's go on to part C, and as you can probably guess that this one's going to not be a function, so we can see an example of that. Here we have the input of 1 outputs 2. Let me read the set of points. We have a set. The first point is 1, 2. The second is 3, 4. The third point is 5, 6. And the fourth point is 5, 8. So we see that input of 1 outputs 2. The input of 3 outputs 4. And the input of 5 outputs 6 and 8. I use arrows. I can say 1 goes to 2. 3 goes to 4. And then 5 goes to 6 and to 8. So since 5 is going to 2 different things, that input has more than one output. So no, this is not a function. And we're going to state specifically 5 has 2 outputs. 2 outputs. All right, so that's our reason. That's how we know that it's not a function. We will still talk about the domain and the range. The domain is all the possible inputs. In this case, just 1, 3, and 5. Those are the only inputs for the function. And the range is the set of all possible outputs. And this function can output 2, or this not function, this relationship, can output 2, 4, 6, and 8. All right, that's everything for this video, guys. Thanks so much for watching. Go ahead and do the Now You Try problems and check back into the next video to walk through those solutions. Thanks again. See you shortly.